In this video here, we are going to be going over standard form. So here's an example that goes with standard form. At a baseball game, it costs $6 per student and $9 per adult. All the ticket sales totaled up were $360. So if we were to put this information on a graph, it would look like this, to where if you had like the point 040 would be up here, and then the point 60 would be here. And so that would be looking at ticket sales for adults versus ticket sales for the students or the kids. So here we go. So sometimes when we have scenarios and situations that come up, there appears to be two slopes. And so you'll notice the wording on the word problem. It'll be numbers per x, numbers per y, or in some examples, it'll be numbers each x or numbers each y or every y. So per, every, each, that's telling you that there is a rate type idea going on. So the other thing with standard form style scenarios is that there's going to be some sort of total type idea going on. So here's a rate, the A, the B, those are rates, and then C is going to be your total. So when we have this AX plus BY equals C, so this is going to be your standard form. Notice we have the X and the Y, then we have the equal sign. It's not Y equals like what we had with slope-intercept form. The other thing with this is neither variable is dependent on each other. So if we're talking like cheeseburgers, like number of cheeseburgers and how much it costs, that's your cost depends on how many cheeseburgers you buy. But for standard form, we don't have that. Now these relationships are also called linear combinations. You'll sometimes hear it said like that. So for this video here, we're going to be going from words and rewriting those scenarios in standard form, and then we'll be going from standard form and finding solutions, and then also going from standard form and rewriting that in slope-intercept form. So those are the three things we're going to go over in this video. So for your formula section, this is standard form here. So again, we have two rate type ideas in our story problem. And so the A there in front of the X, the A, the B, and the C, those are placeholders for values. So the A is going to be a rate type idea. The B is going to be the other rate type idea. And then the C, that is kind of like the total of the story there. Now, it's a little bit more complicated, but I try to make this kind of easy to follow along with as far as what they're talking about. So these are user-friendly definitions, not like formal math definitions. Now remember, slope-intercept form gives us different information. So y equals mx plus b, the m, that's going to be your slope or your rate, and then the b, that's your start amount or the y-intercept. So different information is going to give us different forms of equations. So just to review here, let's pretend you started this year with $53 saved and you continue to save $9 per month. Use T for the months and S for the savings. Now in this case here, the information we have is we have a rate, $9 per month, and we have a start amount, $53 per that you started with. So we have a rate and a start amount. So that means that we are going to be using slope-intercept form. A rate goes there and the start amount goes there. Also notice that the savings, how much you have in the bank, depends on how long you've been saving or how many months. So we do have that relationship here with that as well. So here we go. We're going to go ahead and rewrite this, but instead of the Y, that's going to be S for savings. And then the T, that's going to replace the X for number of months for our independent variable, the time. And then the savings is the dependent variable. So M, that's your rate or your slope. That's going to be $9 per month there. So the M gets replaced with a 9. The B, that's your start amount or the y-intercept. So it says here you started with $53. So that's going to replace the B with a 53 there. And that's going to be basically done for slope-intercept form. Switching gears, different type of information. So let's say you're playing a video game and you're collecting stars and jewels right there and there. And your stars are worth 2 points each and the jewels are 3 points each. And you're going to have, at the end of your level or game, you're going to have 28 points total. So we're going to write an equation. We're going to use S for stars and J for jewels there. Now notice with this, you have a rate, each, and each. You have two rates and you have a total. So with slope-intercept form, it's one rate and a start amount. With standard form, it's two rate type ideas and a total type idea. So, and also notice here, like when you're playing this level, you can get a bunch of stars and almost no jewels. You can get a bunch of jewels and almost no stars. They're not dependent on each other. The same way how much you pay at the fast food place, a burger joint, the how much you pay depends on how many cheeseburgers or whatever you purchase. That's not the same type of idea with these stars and jewels here. So that means we are going to be using standard form. So here we go. We're going to look at the stars are 2 points each. So that's going to be the rate of the first variable is going to be 2. So it's 2 points per what? Per star. So S goes with star, says so right there. And then we're going to add to that 3 points. 3 points for every joule that we collect, so J for joules, and that's going to equal a total of 28 points. So the C turns to a 28. So we replace the A with the rate, the X with what it is, the rate. So and again, with these ones here, it's 2 points per star plus 3 points per joule equals a total of 28 points. So that's kind of the summary statement of the scenario that we have up here. All right, let's have you go ahead and pause the video, try this one out on your own, then come on back and see how you did. So here we're at a clothing store. Shirts are $15 each, jeans $20 each. We're going to write an equation when you spend $100 using S for shirts and J for jeans. So if we notice the information here, it's rate, and a total. We got a rate for the shirts, a rate for the jeans, and we have a total. And also notice the shirts and jeans, those variables are not dependent on each other. In other words, like again, if you're buying like cheeseburgers, how much you spend depends on how many cheeseburgers you purchased. So here we go. So that means rate, total. That does mean we're using standard form. So here we go. Rate for the first one. So it's going to be shirts are $15 each. So that's going to be $15 per shirt. And then we're going to add to that $20 for your jeans. So $20, 20 per pair of jeans. And that's going to equal a total of, how much did we spend? We spent $100 total equals 100. And boom, there you go. So with standard form, writing these out from a scenario, if you know you got a rate, and a total, it's super straightforward. $15 per the first one plus $20 per the second one equals the total there. And again, this is a summary statement for the information that's up here. So you can take these words and you can re-say them here. It's $15 per shirt plus $20 per jean equals $100 total. Sometimes we'll have questions and it won't actually explicitly tell you the rate because you're supposed to already know it. So this is one example here. Like if you're dealing with quarters and dimes, they just assume you know what the rate for a quarter is. So if you're talking cents, right, quarters, the rate for quarters is 25 cents. Dimes, 10 cents per dime, right? Each nickel is 5 cents. Every penny is worth 1 cent. Now, if you're thinking dollars, that's going to be 0.25 for quarters, dimes 0.1, nickels 0.05, pennies 0.01. We can do the same thing with dollar bills. Again, when we're looking at these situations that come up when they deal with money, we do want to stay either all in cents or all in dollars. So your $2 bill would be 2, or if you're thinking cents, that would be 200 cents would be the rate per $2 bill here. Just remember, quick review, solutions for a two-variable equation, y equals mx plus b, or ax plus by equals c. Solutions are the ordered pairs that makes the equation true. So that's kind of the key word there, true. So here we go. So we're going to go and find some solutions to this equation here. We're going to find the solution for when y equals 4 to start out with. So we're going to find the value for x when y is 4. So here we go. So we're taking our equation 2x minus 2x minus 6y equals negative 12, right? 2x minus 6y equals negative 12. But here we're checking for when y is 4. So we're going to replace the y with a value of 4. And next up, simplify, right? So that's going to be a 2x, and then minus 6 times 4 is 24, and that's still going to equal a negative 12. Now we're ready to solve. This is a regular old two-step equation. Hopefully by now you can do most of it, if not all of it, in your head. We want to figure out what x equals here. So we don't want the minus 24 and we don't want the times 2 next to the x. We just want x equals. So we're going to undo this minus 24 with a plus 24 to both sides. So here we go. So 2x, right? negative 24 plus 24, no more constant term on the left side of the equal sign, and then negative 12 plus 24. Think of this as like you're going to subtract 12 from 24, or you have to pay $12. You have a positive $24 in your pocket, so you're still going to have $12 left over after you've done paying off whatever you owed, right? So now we're multiplying 2 times x. We undo this multiply with a divide 2 to both sides. So 2 over 2 is just 1 x. There's 1 x right there. 12 divided by 2 makes a 6. So we know that 6, 4 is a solution for this equation here. Let's have you go ahead and try this one out on your own. When x is negative 9, find what y equals. The solution there. Pause the video, come on back and see how you did. So we know x is negative 9. We're trying to find the y. So we're going to rewrite this equation here, but instead of the x, we're going to replace it with what x equals. In this case, it's a negative 9. So 2x is negative 9 minus 6y equals negative 12. Go ahead and simplify. We can do 2 times negative 9. We have a positive times a negative, so that's going to be a negative. And then 2 times 9 is 18. We still got the minus 6y and the equals negative 12. Now we solve because we want to figure out what y equals, or the value for y. That would make this equation true. So we don't want the negative or the minus 18, and we don't want the times negative 6 on this left-hand side there. So we can add 18 to both sides, and that will undo this negative 18 here. So negative 18 plus 18, 0 18s, just a negative 6y equals negative 12 plus 18 is going to be a positive 6. So now we need to undo the negative 6 being multiplied with a divide by negative 6, right? Negative 6 over negative 6 is 1y, so 1y, perfect right there. We have a positive divided by a negative, so that's going to be a negative. 6 over 6 just makes 1. So when the x is negative 9, the y is going to be a negative 1, and that's a solution to this equation here. Next up, we're going to rewrite this equation in standard form, rewrite it into slope-intercept form. So if you know how to do that, go ahead and pause the video, try that out, come on back, see how you did. So here we go. Basically, in order to rewrite the equation in slope-intercept form, you just solve for y. So if you can go from there, go ahead and pause it and try it. If not, follow along. Here we go. So we want y by itself. So we're going to undo the 2x and the multiply by negative 6. So that way we'll just end up with y by itself. So we can subtract 2x from both sides of the equal sign. So on the left side, we have 0 x's, just the negative 2y, negative 6y. And then here we have a constant term and a variable term. So you can't actually add or subtract these together. So you just leave it as negative 2x minus 12. Next up, we need to undo this negative 6 being multiplied by y. So divide both sides by negative 6. Negative 6 over negative 6 is just 1y. Perfect. That's what we wanted. Now we're going to simplify this side. So both of these terms, the negative 2x and the negative 12, need to be divided by a negative 6. So here we go. Negative 2 over negative 6, or divided by negative 6, is 1/3. It's going to be positive because we got a negative divided by a negative, and then we still have the x there. And now we have a negative 12 divided by a negative 6. Negative divided by negative is, again, a positive, and then 12 over 6 makes 2. And boom, now we're in slope-intercept form, right? The slope is going to be 1/3, and the y-intercept is going to be a 2. So now that we've dealt with all 3 forms of linear equations, slope-intercept form, point-slope form, and now we've introduced standard form, we can see this line here can be represented with all 3 forms. So with y equals negative 2/3 x plus 6, right? Our slope is down 2 over 3. Same thing on point slope form. Here we have the y-intercept right there. And then here we have actually several different points to choose from for our point slope form. So if we're using the point 3, 4, 3 replaces the x1, 4 replaces the y1. And then on the next video, we're going to be talking about standard form and graph. So stay tuned for that. So do make sure you get the standard form in the formula section of your notebook. Again, it's a x, a y, then an equal sign, and then some sort of total there. So in front of the x, the coefficient, that's kind of the rate of the x variable. And then the b, the coefficient of the y, that is the rate of your second variable. And then c is a total type idea.